So welcome back, dear friends. Now we'll discuss here atomic or periodic property. So see here the properties which are directly or indirectly related to the electron configuration, and which shows a regular gradation. We show the regular gradation when we move from left to right in a period. In a period, when we move from left to right in a period, or from top to bottom, in a group of a periodic table are called as what? Are called as periodic properties. Are called as periodic properties. So the main factor that influence periodic properties are, so say, which are those main factors? First main factor is nuclear charge. First main factor is what? Nuclear charge. So what is nuclear charge? Say the total charge of all the protons in the nucleus is called as nuclear charge. So see here, the total charge, the total charge of all the protons in the nucleus, it's called as nuclear charge. So another factor here, see, which are those another factor, that second one, screening or shielding effect. So see here, screening or shielding effect. Screen, some electrons they are screen or shield to that outermost electrons. Okay, so see, the term shielding effect refers to the decrease in the attraction between the electrons and the nucleus in an atom. When additional electrons are present in different orbits, the electrons repel each other slightly. So this repulsion force works against the nucleus attraction force. This repulsion force works against the nuclear attraction force, decreases the attraction between the electrons and the nucleus. So say how we can show this diagrammatically. So see here, it is your one nucleus. This what? Nucleus. Now see here, this was your nucleus. So see here, it is your suppose first shell. Now here second shell. Here what your third shell. We can say it is our what your valence shell. So suppose here also here one electron. Okay. Suppose here also one electron and here also one electron. Okay. So these other electrons. So this also electron. This what will happen here? Repulsion. So this what your electron, they are what they are doing? They are doing repulsion, and this also electron what they are doing? These are also what electron and doing what? Repulsion. Okay. Now nucleus is trying to attract these outermost electrons towards itself. Okay, force of attraction. So here what we call force of attraction. Here main role of nucleus is what? Nucleus is trying to attract. Nucleus is trying to attract outermost electrons towards itself, and these other electrons they are repelling. So that's why this repulsion force works against the nucleus attraction force. So decrease the attraction between the nucleus and the outermost electrons. Okay. So what will happen? Automatically, suppose we are going to discuss here how we can work our effective nuclear charge. So say that now we will discuss here on the base of this all. Say that third part here. That third part is what? Effective nuclear charge. So this effective nuclear charge we can also represent it Z effective. Z means what? Atomic number. So atomic number means what? Number of protons. Okay, so whatever that effect is going on, what? Number of protons. So see, we can also mention in that, we can also mention here, in a single electron system and multi electron system. So see here, we can also this explain with the help of this diagram. So see here, it is here an atom, here a nucleus. Okay, here one electron. This one here single electron system, and here I am drawing. So this is a nucleus, first shell, then second shell, then third shell. Okay, now see, as you know, this 2 8. Okay, suppose 2 8 2. Okay, any we can take example here, this 2 2 8 and 2. Now here what will happen in a single electron system, and here what? Multi electron system. In single electron system, what will happen? All hold of nucleus is on this single electron. All hold of this nucleus is on this single electron. But in multi electron system, all attraction of nucleus is on not on this single electron. Okay, so these some other electron, they are repelling each other. So this result in the decrease in the nuclear attraction on the electrons of the outermost orbits. This the part of nuclear charge works. The part of nuclear charge works against the outer electrons. It's called as what? Effective nuclear charge. Okay. So what will happen here? Nucleus is trying to attract this outermost electron towards itself. So automatically size will what happen? Decrease. Okay. So see here, in that we can mathematically express by Z effective is equal to total nuclear charge, that is Z, minus screening constant. Screen, some electrons, their role, what? Screening constant, and screening constant, their symbol is what? Sigma. Okay, now what will happen? So here, single electron system and multi electron system, understood? So it is very much important here, single electron and multi electron system. In single electron system, all hold of this nucleus on this single electron only, but in multi electron system, all hold of not this single electron. Okay, so therefore nucleus is trying to attract that outermost electron towards itself. So automatically what will happen? Size will decrease. So trend. So from this what we conclude? We conclude one trend here, important trend. So along the period what will happen, and down to the group. In a period from left to right, Z effective increases. So Z effective increases means what? Okay, atomic size automatically will decrease. And down to the group, Z effect decreases. Z effective decreases or remains constant, so it is very much important here, this trend from what? All this data whatever we studied, nuclear charge and effective nuclear charge. Okay, so very much important is, suppose Z effective increase, so atomic size will decrease. Z effective down to the group, what will happen? It remains, decreases or remains constant. In Z effective increases means what? Left to right, atomic size will decrease. So whatever next part, we will discuss it next lecture. Thank you.